Load balancers in distributed systems with OS and SageMaker. Definition: load balancers distribute incoming network traffic across multiple nodes or instances in a distributed system to optimize resource utilization, enhance performance, and ensure high availability for large language models (LLM) and retrieval augmented generation (RAG) projects. Leveraging AWS, Amazon Web Services, and SageMaker. Key components: AWS Services, SageMaker, fully managed service for building, training, and deploying machine learning models at scale. Integrated with AWS load balancers for optimized model deployment. EC2, Elastic Compute Cloud instances that can be dynamically load balanced to distribute incoming traffic across multiple instances. Elastic Load Balancing, AWS service for automatically distributing incoming application or network traffic across multiple targets, improving fault tolerance and scalability. Auto Scaling, automated scaling feature for EC2 instances, working in conjunction with load balancers to adjust capacity based on traffic demands. API Gateway, managed service for creating, publishing, maintaining, and securing APIs, facilitating communication between distributed components. Load balancer techniques. Application load balancing distributes HTTP/HTTPS traffic based on application level information, such as URL paths or headers. Network load balancing routes traffic based on network level information, such as IP addresses and TCP/UDP ports. Load balancer health checks regularly monitors the health of distributed nodes or instances and routes traffic away from unhealthy instances. Elastic load balancer configurations configures load balancers to handle varying traffic patterns and optimize performance in distributed environments. Benefits: scalability, scales application and network traffic distribution to handle increasing user requests and workload demands in distributed systems. High availability, improves fault tolerance by distributing traffic across multiple nodes or instances, reducing single points of failure. Performance optimization, enhances response times and throughput by efficiently distributing incoming requests across distributed resources. Simplified management, centralizes traffic management and routing logic, simplifying administration and operational tasks in distributed deployments. Cost effectiveness, optimizes resource usage and operational costs by efficiently utilizing distributed resources with load balancing techniques, tools and technologies. AWS Elastic Load Balancing service for distributing incoming application or network traffic across multiple targets, ensuring high availability and scalability. AWS EC2 Elastic Compute Cloud service for resizable compute capacity in the cloud, integrated with load balancers for dynamic traffic distribution. AWS Auto Scaling, automated scaling feature for EC2 instances, adjusting capacity based on predefined metrics or policies in conjunction with load balancers. CloudFormation, infrastructure as code IaaC tool for provisioning and managing AWS resources, ensuring consistency in load balancer configurations. AWS CLI, command line interface tool for efficient management and configuration of AWS resources and services, including load balancers. Challenges: configuration complexity, setting up and configuring load balancers to handle specific traffic patterns and performance requirements in distributed environments. Monitoring and health checks, implementing effective health checks and monitoring mechanisms to ensure load balancer reliability and performance. Security configurations, Securing load balancer configurations and traffic routing to protect against potential vulnerabilities and attacks in distributed setups. Latency management. Managing latency and response times across distributed nodes or instances when routing traffic through load balancers. Scalability planning. Anticipating and planning for load balancer scalability to accommodate future growth and traffic spikes in distributed deployments.